Welcome to the Control Engineering webcast, Increase Visibility and Plant Availability with Predictive Maintenance, sponsored by Endress+Hauser. I'm your moderator, Mark T. Hosky, and I'm happy to join you today on behalf of Control Engineering. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on the computer or adjusting the volume on the webcast platform. If you're having technical problems with the audio or the slide presentation, click on the question mark at the top right corner of the screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type the message in the Ask a Question box and someone will get to you as quickly as possible. Type the questions for our speaker in the Ask a Question box on the left side of the screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week to the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of the screen. Those documents will also be available with the on-demand version of the webcast. Now we'll hear from the sponsor of today's webcast, Endress+Hauser. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Please stay tuned after the video for today's presentation.
Did you know that a vast majority of Endress+Hauser products for domestic customers are manufactured right here in the USA? This local production helps us be more flexible with creative delivery options, even during supply shortages. We're prepared to solve your complex process automation issues and ensure your production lines are running on time. Partner with the people for process automation.
Now for the learning objectives for today's presentation. Predictive maintenance and how it can work within your plant, the benefits of heartbeat technology and how it impacts your maintenance plan, improve plant visibility and processes through predictive maintenance, reduce process interruptions, and expense with heartbeat technology. Go over these learning objectives and present. I'm happy to introduce Keith Riley. Keith Riley is National Product Manager for Level and Pressure Products at Endress+Hauser USA. He's responsible for all aspects of product lifecycle management, including identification of emerging market and technology trends, development of product or industry-specific value propositions, and managing the strategic roadmap for a diverse offering of pressure and temperature products. Overall, Keith has more than 22 years of sales and marketing experience with process instrumentation that covers a wide range of technologies. Thank you for joining us, Keith. Please go ahead.
Thank you, Mark. Welcome, everyone. I appreciate you taking some time to share this topic with me this afternoon. So we'll go ahead and get started. The first thing we're going to do is do a little history here. Let's look at how things have been working in the process industry as far as instrumentation is concerned, really up to this point. Primarily, the concern was, do I have good measurement? Am I getting good factual information out of my device as far as my primary variable is concerned? Beyond that, in a lot of facilities, the concept was, then we'll just have a run to failure concept with the instrument and replace it when necessary. While that may have been good in the past, we're finding, and most facilities are finding, that's not adequate anymore, especially when you look at the last couple of years, some of the challenges that have happened in a supply chain environment. Running to failure is really not a productive way to operate anymore. So now we're seeing questions along the lines of reliability. How reliable is that device? Can I depend on it being there when I need it to be there? Availability. Again, something else that comes to mind as far as the device is concerned. Ease of use. While we want more information out of it, it can't come at the expense of complexity. That's not going to be a benefit long term if getting more information, better reliability, and predictive maintenance is going to come at complications. Safe. Obviously, we have to always be conscious of risk mitigation. Is everything we're doing still going to allow us to have a safe environment, both for the process and the employees that are involved? And predictive. I've already touched upon this. How can that device help me predict what's going on and better manage my maintenance and downtime as I'm looking at it? And finally, connected. Can I make that information available to the people that need it when they need it? The answer to all of these questions comes back to a simple term for Endress+Hauser, which is heartbeat. Heartbeat is our method of being able to provide better reliability, predictive maintenance in the process industry today. When we look at heartbeat technology, there's really three aspects to it: diagnostics, verification, and monitoring. And they all play interrelated but different roles in the process. Diagnostics, by its very nature, is going to be reactive. It's letting you know when you have an issue. Heartbeat is what we term preventive. All right. It is looking ahead and noticing an issue before it turns into a diagnostic warning. And monitoring, is predictive. This is where we're getting into the area of predictive maintenance. How do I plan further ahead and avoid costly shutdowns and extra maintenance hours, which I really don't have the time for today? We're going to begin our discussion with diagnostics. And yes, some of you are probably thinking, that's nothing new. All of my instruments have diagnostics already. And you would be correct. But like a lot of things in this world, not all diagnostics are created equal. All right? The diagnostic coverage for heartbeat goes well beyond your typical diagnostics. We do look at the entire system. So you're looking at all of your I/O modules, your power supplies, your sensor modules. Is the temperature at that sensor within an acceptable range? You are looking at a wide range of data points that can have an impact on the device itself. All right. And really, this is where you start to get into the differentiation, is how do you use that diagnostic information? By its very nature, it is reactive, but we can minimize that at the same time. What you're seeing here is by using the Namur NE107 diagnostic concept, we can make things easier for the maintenance staff. First off is we have these dashboards. As you're looking here, if you see a dashboard, a nice green check marks, that means everything's healthy, all right? The red X, obviously failure, we have a serious issue. But then you have the other dashboards as well, because you have varying degrees of what the instrument may be experiencing. Could be a function check, should be out of specification, could be just maintenance required. This immediately helps the technician in knowing, all right, if I've got a failure, I know I don't have a valid reading any longer. This is something that has to be taken care of now. Now, when you get out of specification, maintenance required, you're still getting a valid signal back to your control system, and that immediately tells him, I need to figure out what's going on, but it's not a crisis. We don't necessarily have to stop the process just simply because I'm out of specification or I need maintenance. Now let's go a little bit deeper. And I think most of you will recognize what I'm about to say. In most circumstances, let's say the technician is out in the facility, notices a flashing display, which means I better go look at and see what's up with it. He gets there, he has a diagnostic warning on display, something like, let's call it a W360. So it's a sensor code. It's a code to tell you that there's something wrong. At this point, what's going to happen? one of two things. He's either going to get on the radio and call back to the control room and have somebody look for the manual for that particular instrument, find the list of diagnostic codes, which is then going to tell everybody what the issue is, and then they're going to have to look and see what the solution to that problem is. If he doesn't radio back to the control room, he's going to walk back to the maintenance area and do all of this himself, eating up a lot of time at that particular point. When you're looking at modern diagnostics through heartbeat, not only are you getting the dashboard display you're seeing and the warning, you're also getting a plain English description on the unit of what the actual issue is. It's telling you W360 means this. I'm out of specification of the transmitter temperature, just as an example. All right, so it tells them immediately what's going on there. Now let's take the next step. The display has a set of push buttons. Using the push buttons on there and going one or two steps into the menu, the instrument itself will actually give you the solution to the problem. So all of this is done in roughly 5 minutes versus the 30 to 45 minutes that would typically be required to go back, find the right documentation, find the issue, and then decide what is it that I need to be doing about it. So it's a great time saver. And again, it goes straight to the productivity of that facility. The next thing we're going to transition to is verification. This is our predictive portion of heartbeat. All right, heartbeat verification is first and foremost a qualitative assessment of the device. And there is a distinction. I'm using verification. It is not considered a calibration, which would be a quantitative evaluation. It is verification, which is a qualitative. All right. It also can take place in situ, meaning the, the instrument is going to stay in service in the process, and it's also not going to interrupt the output to the control system. So you can run a verification at the same time that you're continuing to get measurement information back at the control system. Now we're looking at total test coverage. All of our heartbeat verifications get 95% or better total test coverage for that device. So you're getting a good overall coverage of the electronics, how they're performing, and knowledge that that unit is giving you a good report on the health of the device. In certain instruments, you're also getting some process-related information as well. Again, that's going to vary a little bit from instrument to instrument on what it's able to supply. But again, we're providing a good deal of information to be able to determine, is this unit healthy and is it operating as it should be at this point in time? We also strive to have redundancy. In other words, the majority of our instruments with heartbeat verification also have a redundant reference built into the device. This reference takes the condition of the device when it was new, going through manufacturing and through its final testing, and records the values of the device right then and there. Then it uses in verification that to compare the current as-is state to that redundant reference that is there. That's giving you good information that it is current and that it is reliable so that you can trust the verification pass-fail information that you're getting. All right. We also go to the step of getting third-party attestation on this as well. That's why you see the two signals there. When we're working on the verification, we send this off to that third party to definitely assure that you're getting a method that's according to ISO 9001 and can be trusted. And of course, like everything, if it's not documented, was it actually measured? In this particular case, heartbeat verification can easily be documented from the instrument. You can generate a PDF that can stay with the instrument and be printed out on demand, or just saved immediately after that you have done the heartbeat verification. So then you can save it as a PDF, save it electronically, do a printout, whatever your particular process is geared towards as far as your record keeping. Now let's get to the meat of it. The question is, okay, heartbeat verification sounds good, but why should I care? What can it actually do for me in a day-to-day basis? Let's look at your calibration cycles. What you're seeing right now is a typical calibration cycle that might go on. Let's assume the gaps you're seeing between there are every 12 months, which is a very typical time frame. Right? So this is what you're doing today. Now let's look at how heartbeat verification can step in and enhance this. What you're seeing right here is you're running verifications in between your normally scheduled calibrations. Remember, it's in situ, and it is not interrupting your signal, so you can do this without any process interruption, and what it's generating is risk mitigation at that particular point. You're calibrating every 12 months. If this is a critical measurement and it passed on year 1 and didn't pass on year 2 during that calibration, how do you know where in that 12-month cycle that it fell out of calibration? You really don't. Heartbeat verification at least gives you an indication that the device is performing as specified at that particular point in time, so you have risk mitigation within your system. We have had some people that then go to looking at running a heartbeat verification and extending their calibration cycles, not as a substitute for calibration per se, but a way to extend those calibration cycles because calibrations require additional downtime and additional maintenance hours. This reduces it. We've had customers with one of our devices, a liquefont, which is a point level indication that you can run verification on. They have told us that every time they run verification instead of a calibration, it saves them a lot of hours and a lot of money because typically they would have had to drain the vessel, take the unit out, run a calibration, put it back in, and then fill the vessel back up. And just that time alone could be thousands of dollars. So the fact that they can do it in situ, real time, is a big productivity aspect for them. All right. There's also the idea of new installations. It's common practice once you get a new installation going, even though the instrument came straight from the factory and is going in, is to use a calibration before you start up. Now, if you've got the calibration report from the factory showing everything's good, it's possible to run a heartbeat verification at this particular point and use that instead of that timely calibration. And you're going to shorten your commissioning for the site. You're going to be able to get up and running sooner and start to make productivity or start to make your product that much faster and turn a profit. So that's another way you can use verification in a real world situation. All right. Now we're going to go on to the last portion of the heartbeat technology message, which is monitoring. Right? And this is where you'll see you're getting into predictive maintenance. The nice part about predictive maintenance is we're not just talking about predictive maintenance for the instrument. There's a lot of information the instrument is seeing that you can use for predictive maintenance for your system. As you can see on the screen right now, you've got corrosion, abrasion, mechanical stress, thermal stress, all sorts of other things that are outside the actual instrument itself that now your smart instrument can help you detect it ahead of time so you can better manage your process, reduce downtime, and increase productivity. Let's look at the liquefont. I mentioned this earlier. Here's another look at it, and we'll talk about fork frequency and corrosion. What you're seeing on the right-hand side there for a corroded fork is not unusual in some chemical processes. Now, the nice part about liquefonts is this is going to incorporate all three aspects that I just talked about heartbeat. Liquefonts do an excellent job of 24/7 diagnostic. It's constantly watching the frequency of those forks, and it has an embedded bandwidth that it looks at for either buildup or corrosion, and due to a change in frequency. In corrosion, the frequency of those forks is going to increase because there's less material being vibrated. And we're monitoring that 24/7. So no matter what, you will get an alarm once it reaches a certain point. That's great, okay? Now let's look at heartbeat. When you run that heartbeat verification, you're determining the health, but you're also getting a readout of that point in time of that frequency and the last 8 frequency checks that happened, so that you can start to trend what's going on. So as you're starting to see an increase in frequency, similar to what we're seeing on the chart right here, that's going to give you an idea, hey, it's growing based upon that slope. I probably need to do maintenance or replacement of that within the next 1 or 2 months, as an example. So now you've got that predictive maintenance simply by looking at that trend that's provided you through your verification report. Let's jump ahead to the latest development for us, which is going to be on our heart-based electronics, which come out in that 8 and 16 heart output that's now available. That actually allows you to monitor the frequency into 24/7 as part of your heart output variables, so that you can see that in real time, what is happening with that frequency. You can establish bandwidths within the instrument itself, so that it will alert you then through your heart notification that you have crossed that bandwidth. It doesn't mean that it's ready to fail, but if you set that bandwidth up early, you will know that you now need to plan maintenance. So again, this is the predictive maintenance and helping you manage your activities on a daily basis. A similar example on level is our guided wave radar and foam detection. Foam can happen in a lot of processes. It can be problematic, especially if it gets into the piping, the drain piping, the exit piping out of the process. Can also interfere with a lot of other things. So we don't want it, but at the same time, foam suppression is expensive. You don't want to necessarily use more foam suppression than you need to, because it is a big operating cost. What you can do with a guided wave radar is, again, set up a bandwidth of acceptable signal strength. As you can see on the left-hand picture, that's a vessel, no foam, nice, sharp, well-defined level indication. Now you go to the right, when foam starts to develop, you still have level indication, but the signal is not as sharp and it's weakened. By monitoring that, you're going to know immediately that you have foam, that you need to apply your foam defoaming agent to address it. That can happen through a secondary 4-20 or switch output that you have in the electronics. So it's an automatic thing. It takes care of itself. Once the signal comes back up, that reverses. The foam defoaming agent stops, and you never lose your productivity, never lose your operation or your signal once you get things set up properly. So again, not only does the time savings, it eliminates downtime, and it eliminates costly use of defoaming if you don't need to be using it. Now we're back to the pressure. All right, mechanical stress, I mentioned that earlier. Every pressure transmitter is making hundreds, if not thousands, of pressure measurements every second. It's really taking all that information and it's consolidating them into the output that you actually see at your control system. So what that means is when you have pressure spikes, that device is seeing them, but they're so short, millisecond type pressure spikes that you're never going to see it on the output of the device. However, that can be very meaningful to your process as a whole. Typically, those kind of microbursts of spikes can be a valve issue, water hammer, other related mechanical issues that are happening within the system, not the transmitter itself, but obviously within the system, and that can be damaging both to the piping, both to your valve. Valve failure is going to be very costly, and it's going to create a lot of downtime. things that you want to know about early and address before they do turn into a crisis. That's just one of the kind of pieces of information that heartbeat through a pressure transmitter can help supply to you so that you see it. Similar to what you've heard me say all along is we can set up a bandwidth on both amplitude and frequency of those spikes so that once we extend beyond that bandwidth, we're going to provide a notification to the control system through heart or on the device itself, if you're just using 4 to 20, that you have an issue and that you need to come to investigate it. Again, giving you that advance warning that there is a potential issue within the system. The final example that I'm looking at this particular point is buildup. And for that, we'll talk about mag meters and flow. Here we're doing something a little bit differently than we talked about. We do create an indice of buildup because the mag meter itself is going to detect the buildup. But by an indice, I'm talking about the 20%, 30% that you're seeing there. That's not a direct correlation to say, yes, I have 20% buildup within my size of pipe. It's an attempt to give you an indication of what's going on. At that point in time, you can go measure the buildup, and then you've built up a history at that point that 20% is 3 millimeters, 30% is 5, so that now in the future, when you continue to see that, you can understand the degree of buildup that's happening within the pipe, and at what point do you need to go clean the system and get rid of the buildup. So again, it's providing you that predictive maintenance, letting you plan your cleaning, plan it for when you typically are in between processes or not using the device versus a emergency shutdown. This brings me to the next step of what we're looking at, which is what do we have to look forward to in the future? You've heard me talk about how you see this information. A lot of it is visible through the instrument. A lot of it is visible through other devices we have. If we have Bluetooth instruments and you use Bluetooth in your facility, you can easily see this on connected devices, on handhelds, things like that. You can get some of this information through your heart variables back to a heart card in your control system if that's how you're using it. But really what we're seeing is the next generation is when we're going to get things like industrial Ethernet, things where you can get all of this information almost in an unlimited situation and direct it either to a secondary physical server that's in the facility, maybe to a cloud system like Endress+Hauser Natillion, and also have that maintenance information stored separately from the control so the right people have access to that data when they need it. That is the ultimate goal for most facilities is control is control. We need that on a daily basis. Maintenance, predictive maintenance is a separate function, and we need to have those two clean and separated, and that is going to be the next step that we see out of most facilities is having that data where it needs to be in front of the people that need to have it. As I look at to give you an example of the kind of devices you can get today with heartbeat technology, we have by technology, we've got flow, we've got Coriolis, thermal, point level, continuous level devices. All of these devices, even into our analytical, all have heartbeat technology available to them. So our full product basket has this technology associated with it. When you want to look at individual model codes, here's a list of the devices that specifically you can refer to get that information and make sure that you have heartbeat technology, or you can look into applying the heartbeat technology so that as you're looking for future plans. All right, that is the extent of my presentation. Obviously, we have plenty of time now for any questions. So we'll be happy to entertain any and all questions that you may have for us.
Great. Thanks very much, Keith. Now our presenter will answer the questions from the audience. Please type your questions for Keith in the Ask a Question box on your screen, and we'll get to as many questions as time allows. Questions that we don't get to today will be posted online with the archive version of the webcast. Please remember to download a certificate of completion and a copy of the presentation by using the Event Resources tab on the left side of the screen. So on to the questions. Please, as we're going through, type your questions for the presenter into the interface. So here's one. I have existing Endress+Hauser instrumentation. Can I add heartbeat to them?
Possibly. I know that's a bit ambiguous, Mark. If it's a device that is currently available with heartbeat, it is possible to add heartbeat onto that. If it's, say, an older device, I'm going to use a general statement here that's maybe 5 years old that was never available with heartbeat, the answer is no. It does have to be a device that is available with heartbeat, and if you didn't purchase it that way, it can be added.
Great. Does the asset information feed into our existing control system or asset management system?
That's going to be a bit conditional as well. Obviously, as you've heard, a lot of this, the monitoring device information and everything can be shared over a heart variable, but if you're not using a heart card directly on your measurement, it's going to be more of a manual upload into the asset management at this time. Again, I'm back to the point, looking forward, that's the beauty of what we see in the future with some of those extended protocols like industrial Ethernet protocols. Then the gathering and the sharing of that information is going to be much easier for somebody moving forward.
Great, thanks. So I have nearly 1,000 instrument tags in service. Which one should I consider adding heartbeat to?
Good question. We get that quite a bit. Let me give an example. One thing I didn't talk about on pressure was heartbeat verification on pressure. You're covering all the electronics, things of that nature, but it's not a calibration at the same time. What we found for most customers is they discover that their standard protocol is all their pressure transmitters get calibrated every 12 months. Now, when they really look at it, probably only 20 to 30% of those units are critical measurement units. At that point, they're looking at, okay, we should be looking at those 20 to 30% and make sure they have heartbeat that we can run verifications on for that, if nothing else, for the risk mitigation aspect to it, because those are the ones that were, excuse me, I said that backwards. They're going to look at those on the 70% because, again, they're looking at risk mitigation, but it's not critical measurement. They can easily determine that the device is operating correctly, and then maybe that 30% they still do the calibrations on. That's one thought process behind it. Okay.
Good. What protocol is used to communicate with the field devices here?
Heartbeat itself is protocol independent. And one thing I forgot to mention when you asked me about the asset management is heartbeat verification itself is a DTM-based communication. So again, it's independent of the protocol. You can do it typically you're going to do it on a point-to-point. If you are using an asset management that we can drill down to the instrument where we're using the DTMs, we can use that to get to it as well.
Good. Let's see. Where do the heartbeat messages go? To an Endress+Hauser support center, to an application at the user site, or someplace else?
No, the heartbeat is there. It's kept locally. again, the verification you're saving on the device, all right, or you're typically going to go ahead and save it to the device you're using to communicate with so that you've got the PDF stored. Anything that's on a monitoring, again, is going, if you can set it up for part of a variable output on your hard card, that information is going to go to you so that you can see it. So it's all kept locally. What you saw before was one idea moving forward when we said a billion on a cloud-based system. That's one particular solution. If you'd want to use Natillion, obviously, once those kinds of industrial Ethernet systems are more readily available, it could go wherever you need it to go.
Good. Do I need a certain kind of network to make it work?
No. Again, Endress+Hauser is very network and control system agnostic. We support most of the typical protocols that are out there. And again, this is a system that's embedded in the instrument is probably the best way to put it at this particular point in time. So as long as we can communicate via a DTM with the instrument, we can employ the heartbeat functionality.
Good. Is there an adapter for adding the heartbeat technology to instruments from other suppliers?
No, unfortunately, this is dedicated to Endress+Hauser technology.
Good. What percentage of industrial processes use diagnostics or monitoring? You talked about both in the presentation.
Right. That's a good question. I'm not sure I have a good percentage answer for you. I can tell you that more and more customers, that is really what's on the forefront of their mind, because downtime, reduced maintenance is really something that everybody is struggling with. So it's certainly an increasing topic. Employment, I think, depends upon, again, their process and what we're looking at.
Good. Can the monitoring and diagnostics capabilities be added to non-Endress+Hauser? No, okay, we addressed that one. Phrased a different way. Okay, what's a typical first installation for someone just starting with diagnostics and monitoring?
Honestly, I would say it's probably on a non-critical, because again, there's a learning curve. You want to see how it works. You want to be able to, again, reduce your risk. So it's probably on more of a monitoring measurement versus a critical measurement. But we see a lot of people quickly transfer over to some of their critical measurements at the same time once they become comfortable.
So you would think that people would start with their most critical ones first, but maybe they're going to do a pilot to begin with and start with some non-critical ones?
Right. Much better way to put it, Mark. Yes, absolutely. They're going to pilot or experiment on a non-critical just so that they can get a feel for it, understand, the nuances of it a little bit. And then again, I think they will transfer this to a broad range, including their critical, once they've got past that step.
Maybe you want to talk about training at this point, since you were talking about familiarity and launching with the technology. What training might be available with this?
I think that really the training is just the comfort level of some of the monitoring. As I said, the buildup detection, there's a little bit of modeling involved on something like that. So it's not just, hey, I turned on buildup detection and I'm going to get an answer out of it, okay? So it's functionally, it takes very little training to actually do it, because the device through the setup procedures is very self-explanatory, but it's going through that phase of, okay, this reading indicates I've got 2 millimeters, 3 millimeters of buildup. So you're getting through a little bit of that modeling phase. I would say the same thing is true of some of the other, when I talked about bandwidth setting. Did we get the bandwidth set properly? So we came close. We're watching it. Maybe we need to tweak it. But the actual act of setting up the device is very straightforward.
Good. As we continue to work through the questions, please, if the audience would add any additional questions, we'll get to as many as time allows. And here's the next question. Are there cost comparisons of how much traditional asset management costs compared to this?
I'm better equipped to kind of go back to that Liquifont example, to reiterate that by using verification. The customers we've talked to indicate by the time you take into account downtime, reduced risk, because remember, every time you remove an instrument from the process, you're probably also connecting it from your control loop. So every time you handle it, you risk damage to the device, which there's risk, there's potential additional cost. The same thing goes back into rewiring. Did somebody damage the wiring? Did they not wire it correctly, which means it's going to cause an issue with the measurement once you think you're back up and running. So the cost for me is all those things, and the downtime when you're looking at several thousands of dollars each time you're going through some of those physical calibrations or other things versus the very limited cost addition of a heartbeat verification and monitoring functionality. That's really what your comparisons at that point.
To follow up on that, you did the graphic where the heartbeat could be added in between calibration events. And so
Right.
by extending those out, that would certainly be a cost comparison. When you talk to customers about doing that, what are some of the considerations in extending those calibration times?
I think it comes down to trust. I'll be perfectly honest. They have to see the value in the verification and learn that, yes, even though we have the third-party attestation and things of that nature and the redundancy built in, you have to say that, you know what, you're right. That is trustworthy. We are getting good information. It is truly healthy when it says it's healthy. And then over time, they will probably consider extending some of those calibration cycles at that point.
Good. Can inline measurement device testing take the place of offline testing and calibration? So you've addressed some of that by extending out. I don't imagine. Yeah.
Again, I caution everybody, verification is just that. It is a qualitative assessment. It is not necessarily covering everything that you would cover in a complete calibration. So there is a difference. You're certainly not going to see any deviation information, things of that nature. So while we certainly encourage everybody to take full advantage of things like verification, we're not advocating that you don't calibrate anymore at all either. I think it's a very conditional case-by-case situation on what makes sense for that particular process or that particular measurement.
And you did mention the documentation is involved, so you can create a
Yes.
immutable PDF as documentation depending on what kind of process you have or what kind of signatures are required.
Yeah, absolutely.
So let's see. Does the asset information feed into an existing control system or asset management system? What can you do with the data to help supplement other systems? What kind of system integration might be necessary?
Can you repeat that? Make sure I understood it correctly.
Yeah, so does the asset information feed into an existing control system or an asset management system? What would you need to do to feed that information in?
Again, we're back to that. A lot of that information, we can send some of it out in the form of a hard variable. So obviously, if you can pick that up into your asset management system, it's there. Some of this, again, let's just use verification. You ran the verification, you've got the report. That information, if you're storing it in your asset management, is going to be a manual upload at that particular point. It's not necessarily going to be automatic. if I follow the question properly.
Yeah, yeah. So it might require some integration to get it to connect it to other systems.
Yes,
Yeah.
yes.
Please, if audience on the webcast live, if you have additional questions, please go ahead and submit those now. We'll get to as many as time allows. So how is monitoring different than diagnostics? And maybe talk a little bit about why the two are not combined.
Good question. I mean, diagnostics by its very nature is reactive. So I guess that's the basic answer to it, where monitoring is trying to be predictive at that particular point. The other thing is, I would say diagnostics are solely limited to the instrument, where the monitoring is looking outside the instrument as well. It's really looking at the process and trying to give additional insight into what's happening in the process. So they serve related but still separate functions.
And now might be a good time to remind people that today's flow meters, for instance, can do a whole lot more than flow. Could you talk a little bit about some of the measurements that are available?
When you're getting into your flow measurement, obviously you've got some density measurements you can get out of them. Again, you see where we can do some buildup and abrasion data that can come out of a flow instrument. That now all of a sudden we're starting to get outside, as you said, the primary measurement capability of the device. And I know I'm forward looking here, but that's why I'm so excited about the future of incorporating heartbeat into some of these extended protocols that will be coming up, because to your point, we've seen that already with flow and Ethernet IP that we've had on some of our flow devices for a while, Mark. That act is much easier to gather back to than it is necessarily in a, I'm going to say, traditional instrumentation 4 to 20, things of those nature.
Good. Does the software part of it require a standalone server to be able to operate? You mentioned a little bit about the cloud.
No.
How would it be configured locally? What are the options?
You could do it either way. I see that as just the natural progression, because most customers don't want to combine their maintenance and their control if they can avoid it. So at that point, I just see that as once we get to that capability to do that efficiently and easily, separating those two is the natural progression. But it's certainly not a necessity.
Yeah. So a customer comes to you and says, look, we really need to have a better handle on these set of processes. Could you kind of walk through how that would go, that conversation, that process?
I'm going to need to understand maybe what some of the issues that they feel that they're and then we can start to talk about how the instrument can. So again, if it's simply a way that we can, because it's just costing us a lot of downtime, we're obviously going to start to talk about verification, where that's practical, where it's not, depending upon what the service is, what they're trying to do with that part of their process. If we're going to look at things like, again, foam detection, we go through thousands of dollars a month every month because we have a foam issue, and we are eating up our budget, our maintenance budget, in defoaming agent. Then we can have that discussion with some of our level measurement technologies. So it's going to be somewhat conditional on the problems that they're facing, but there's a lot of these that we can look at and show how using the information from our heartbeat technology can give them those insights and increase their efficiency and productivity within the process.
Great. Keith, do you have any other reminders or bits of advice for people listening in?
I think we've covered most of it, Mark, unless there's any other questions from anybody. I think we've given a good overview on the capability of heartbeat technology and how it can be implemented today successfully in a variety of different processes.
Well, great. Thanks, everyone in the audience, for great questions. Between now and when we close out, if you have any other questions, please go ahead and type them in and we'll get to them offline. And thanks again to our great speaker, Keith Riley, for sharing his time and expertise on these topics. I'd also like to give a special thanks to our sponsor, Endress+Hauser, for today's event. And now that we're about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use the information to improve our webcasts. Finally, on behalf of Control Engineering and Endress+Hauser, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.